Hi everyone, welcome to the Space Science webinar series hosted by the Center for Space Science at NYU Abu Dhabi in collaboration with the UAE Space Agency. Our today's speaker is Professor Vijayan S. He's an assistant professor in the Planetary Science Division at PRL Ahmedabad. He got his PhD from Anna University in Chennai. Then he moved to PRL as a postdoc and he has been here ever since. He's an expert in planetary remote sensing of Mars, Moon, Earth, and icy objects. His work is mostly focused on Mars and the Moon. And today he's going to talk about his work on Mars. So, Vijay, thanks so much for joining us, and it is all yours.
Yeah, thanks, Dimitra. Good evening and good noon, all. Um, this talk, I'll be giving some of the results that has been got on Mars. The talk majorly focuses on the impact craters and how the impact craters on Mars are associated with the fluvial processes. So that means the impact is an independent event and the fluvial process which has happened is an independent event. But in some places, the impact has been breached by this fluvial process. I'm be showing some examples for such processes and will tell how diverse and how big fluvial activity has happened on Mars. To to correlate with this impact and fluvial process, let us start with the impact on Mars. This is the topographic Mars of map, and if you see all the circles, most of the circles are impact craters. They vary in different diameters. Um, uh, Robbins and Hynek has mapped and given the number of craters that is present on Mars, whose diameter is greater than 1 kilometers, count nearly 3.8 lakhs. So it's a huge number. That means that much number of craters greater than 1 kilometer diameter is present on the surface of Mars. If we move to uh, the valleys distributions on Mars, it shows that there are nearly 60,000 valleys on Mars. That means they are widespread. And if you want to look over the channels which are there on the Mars, because these valleys are broader one, the channels may be even smaller one, and they will be numerous in numbers. If you look at this number of 60,000 valleys and 3.8 lakhs craters, then the combinations gives that at multiple places, these valleys will coincide with impact craters. Then those are the places or the potential hotspots to look for how the fluvial activity interacted with the impacts and what are the post processes that has happened. Gorge et al. Has given looked into such correlations, and he has uh, made global studies on how the craters and the channels are associated. So he classified into open basin and closed basin, like whether the water was getting into the crater or the water was getting outside of the crater. So that means these are the places where the channels or the valleys associated with the impact craters. That means we have plenty of combinations to study the impacts and how they are associated with the valley networks. So these valleys mostly of fluvial origin. So I'll show some of the evidence, or we can able to find the evidence through the presence of hydrated minerals. Here, if you look at the dichotomy boundary, the region where it is there are n number of craters which shows correlations with impacts and the fluvial associated valleys. So this is also one hotspot when we go for Mars landing. This dichotomy become one potential zone to look for the interactions between these two hemispheres on Mars. So in this talk, what I'll be presenting is I'll be talking about correlating the craters and the fluvials on terms of the sediments and deposits, how the sediments are deposited within the crater, and what kind of environment it is going to tell, whether it is it is a catastrophic or it's a periodic kind of thing. And these sediments will be in the form of fans, deltas, or associated with the channels, because there is a difference between the fan, alluvial fan, and the delta, because you need a standing water body for this delta formations. There are few places where only the fan deposits by fluvial origin is present without the standing water body. And majorly we look into the water sources. What is the source for the water? Whether it is episodic, like a seasonal, it's due to the solar longitude variation, or it is one time and catastrophic. Because there is a huge difference between the event for a catastrophic and episodic. We can able to deduce the evidence for the catastrophic and episodic. So I'll be showing some examples and how these fluvial processes are modifying the impacts. For example, the first and foremost to look is the rim bridge. The crater rim is one of the elevated part in the crater, and they are one of the little hardest part to bridge. If the rims are getting breached, then the water activity or the amount of water, the speed, is to be sufficiently large enough to break the crater. Because the crater which are going to be discussed are in few tens of kilometers diameter, and the thickness of the walls are few kilometers in wide. It not only modifies the rims, but it heavily modifies the floor, because the floor hosts some of these fan or the delta deposits. That means along with the floor, the peak which is present on the surface, they also get altered due to this modification. So I'll be showing examples for all of these, and going to think. If we come into the source for water, some of the major sources how water came or water activity happened on Mars is these four ways. So one is through the groundwater. It's from the subsurface where it has come out to the surface and interacted, and there are few evidence for such activity. The other evidence is for the precipitation. That means the rainfall. That means if it is rainfall, then it brings the questions whether it was episodic or it has a seasonal effect. There are again some quest in determining whether it is whether it is seasonal things, because we need to have strong evidence to understand the precipitation. But there are evidence that precipitation has happened. The other mode or source for the water is the snow ice precipitation. So this is the rain, and there is a difference between snow and ice precipitation, because at higher latitudes, if you go above 30 degrees of both the hemispheres, the snow starts to precipitate on the surface or on the terrain which is having little elevation. So then that may also be the source for what thing. And the final one is the hydrothermal activity, whether after impacts, whether any heat source make the water to come out and form these kind of fluvial deposits. In this talk, I will be giving examples for these three things: groundwater, precipitation, and snow ice. So this gives, there are multiple studies which are already given evidence for these things, but that means all these ways of water can happen on Mars. That means the planet is so diverse, and it is varying with latitudes and longitudes. In the first thing, let us look into the precipitation part, like how the evidence for the precipitation is given and what kind of activity we can see. To decipher this, we look into one part of the dichotomy. If you look at this one, this is the Curiosity rover where it has been landed, the Gale crater, and this is the Gusev crater where the Sprit rover has landed. That means they are few. The difference is just a few hundreds of kilometers, or some 1,200 kind of kilometers. That means these two has already provided the evidence for fluvial related activities because of the in situ measurements. By connecting the dots, what about the in-between space between these two craters, or these two locations, whether they are also fluvial activity rich, or don't have any signs of fluvial related thing? The Aeolis dosa in this part is one of the well-known region where there are very much sinusoidal ridges present over there, which indicates the past fluvial related activity. In connections, we will be exploring this crater name called Riul, which is located, which is shown in this part of the thing, which is roughly 80 to 100 kilometers in diameter, with a huge central peak and lots of dust deposited on the floor. The latitude it's located, it's almost in the equator or 9 degrees south. That means this is the equatorial regions where there is the concept of ice coming towards equator is very less until otherwise the obliquity is too high. What happened in this crater will be explained in the coming slides. What was observed in this crater was there are huge amount of channels. These blue lines indicates the channels, and those almost all the channels are associated with the fan deposits. That means the southern part of the crater or the southern southwest part of the crater is highly distributed with fan deposits, and the fan deposits are individual and they are overlapping. That means one after the other the fan gets deposited. That means huge amount of activity has been happened. This is the topographic image where it shows the depression, and the contour lines indicates when the at the lowermost part of the crater floor you can see the fans started forming over there. So this gives the question like such channelized way, and you see there are long channels and short channels, and there are broader fans and smaller fans. That means diverse activity has happened over there. What are those? If you, this is one of the sinusoidal ridges which has been formed in the crater floor. That means it has formed in between. This is the thing where it has formed in between the peak and the um, wall of the crater. That means it is a valley, a depression where the sinusoidal things are there. And at the termini, you can see the eroded alluvial fan. The reason for this erosion is like the fine grain materials between the ridges got eroded, and the only the coarse grain materials which has been resisting to erosion has been present over there. That means the possible water flow direction is in this way from east to west, and the deposit has happened. The However, at the lower end or the left, top left of the image, there is another fan which orthogonally superposed the earlier fan. That means this is one fan going in the east-west direction possibly, and the other one relatively in the north-south directions. That means two independent fan processes which are correlated at this point of place. That means this should be an individual event and this should be an individual event. In that sense, this crater is witnessing, has witnessed a diverse activity. But how to correlate with the water kind of thing? If you look at into these ridges, they are the only the coarse grain materials are present over there. The rest are all eroded. The blacker parts are the dust which got mantled over there. In further look into the sinusoidal ridge, usually on terrestrial rivers, when there was a small topographical changes, the river tried to change its path because of the upliftment in one side. That is known as the avulsion kind of thing. Usually it starts with an avulsion node where it changes its path, but at sometimes it down the stream it will try to reconnect or rejoin. If you look at this one, this looks like an inverted channel, or only the channel uneroded part is seen in the dissected form. And this sinusoidal ridge which got gone in this way. That means earlier what may be flowing in this, and now in the later it has flown in this part. So this avulsion is one way to decipher where there was a fluvial related activity happened on the crater floor. If this is happening on the crater floor, it has to come from the sloped wall of the crater. So the source will be coming from the walls of this crater. The detailed one where the fan got superposed, this is the eroded fan. If you look at the numbers, the 3780 is this is the elevated one, and this is 3770. So that is a 10-meter difference. So that means this fan is tens of meters thick, and it shows a clear evidence for the superposed deposits. Such superposed deposits may infer whether they are coeval or they are non-coeval, whether any episodic activity happened, or the events which got happening on these craters are occurring at the same time, but due to the spatial distance, they are differing and they are deposited within the crater floor. Within the crater, there are other fan deposits. So these are deposits which which from the crater wall, where you can see the typical inverted ridges which was present over there. Again, these deposits need water to form these type of fan deposits. The other form of fans are the braided channels, because when the channels flow on a flat surface, they'll try to braid and take the small topographic variations, and due to their large extent, the size of the fan formed at the flanks of the floor is relatively larger. And there's another example where this fan, a inverted ridge and the associated fan has been formed. That means this crater has witnessed a huge amount of fan formations, and they are differentially eroded. Differentially eroded indicates that the post formations, the fans are getting modified over time. If you look at one part of the fan where you can see the evidence for the differential erosion is evident, these are the individual mesas or booties which are currently present on the floor of the crater. And they are few tens of meters high. The similar size of booties are there in the March valleys, and the March valleys are very well known for their past fluvial activities. The other associated evidence for the fluvial is the polygons, and we see lots of polygons on the crater floor. That means once there was water stagnant, and that once sublimed or evaporated, it leaves that marks of polygons. However, there are no spectroscopic evidence for this one, because the black thing which you are seeing, they are primary mineral dust. This crater has been reported for pyroxene minerals on the past. That means though the activity is fluvial, but what we are seeing through the reflectance spectroscopy is the presence of pyroxene mineral on the crater floor. And this is how the crater peak and the wall has been located. And if you look it over, this is the floor of the crater, or usually on terrestrial things, the valleys, the channels forms in between the mountains, because all the precipitated rainwater will come from the hilltop, and they will be accumulated over the floor or the valley, and then they will start flowing. Exactly the fan, the inverted ridge, and the fan which formed over there is formed on the surface, on the flat surface, on the floor of the crater, and the source for this one is coming from this part and this one. So the being an equatorial region crater, and there are sources for multiple evidence for fan. The possible thing that happened on this location is the precipitation driven, because if at all there is a snow related deposits, and there are any glacier related thing, we can able to see the evidence which was preserved over there. But in this part of the crater, the channels, the inverted channels, or sometimes even the normal channels, and the associated alluvial fans are seen. And the source from this interpretation leads to decipher that they are the precipitation driven. That means, again, as I said earlier, the precipitation, whether it is a seasonal kind of thing, it is very difficult, but it can be an episodic. How, on what basis is because of these superposed. It's not at one place the fans got superposed, it got superposed at multiple things. That means that the diverse activity has occurred to form these fan deposits on the crater floor. So that's an example for the precipitation. If we move into the snow and ice precipitation, that is other part of how the water related activity can happen on Mars within the craters. For that, the one of the regions studied is just south of the Valles Marineris, and it is, the crater name is called Tigana, and it exactly impacted over a Noachian or a 4 billion old volcanic dome. And there are huge, large number of craters present over there. The focus is on this crater, where within the impact, there was another impact called Digana A. That means a dual impact has happened on this place. However, there is a time difference between this crater formation and the Digana A crater formation. So this crater is located at 23 degrees south. Again, it is not in the higher latitude, so we can not say that it is filled with snow ice precipitation, because as I said earlier, the well-known line for the ice, either in the current ice rich scenarios, 30-degree in both the hemisphere. However, on past, when the Mars obliquity is different, that may be possible that ice may have come in, the snow precipitation might have happened even towards lower latitudes. That kind of evidence has been seen on this crater. Um, if you look into this, the walls of this crater, and the walls host mostly the primary minerals, the orthopyroxenes and the olivines, the phosphorite mineral. As the reason for these two primary minerals is that this has been impacted, this Digana impacted over a volcanic dome, which is a Noachian volcano. And this gives a good opportunity to look into how a Noachian volcano look like and what are the host mineral on that. There are Zio et al. Has mapped the Noachian volcanoes on Mars, but there are not that much evidence given how we a Noachian volcano look like. This is one place on Mars where that Noachian volcano got exposed by these double impacts, and it exposed the primary minerals which is present over there. However, these minerals are present on the walls of the crater because the flows are heavily modified. How they are modified, again, the inverted ridges like earlier cases. In the case of Rio, this is the inverted ridge, and you can see the layers, the look for the polygons present over in different parts of the crater, and they are different eroded layers. That means this crater has been post formations modified by huge amount of sediments which got deposited within the crater. This made to expose, and after the differential weathering we are getting the discontinuous ridges and the possible polygons due to the hydrated mineral, and the layers which got exposed by these impacts. But how these polygons and the sediments occurred within the impact, this is when impact happens, they will be in a perfect circles. But if the eastern part of the Digana has been shows a complete degradation or breach, that means that is the rim breach part. Something has breached and the deposit has happened within this. This is the example where this fan has deposited from the eastern wall. That means a large amount of sediments mixed with water has come and started to breach this part of the wall. This length is roughly 800 meters and the thickness goes to around few hundreds of meters. Such a erosion of to erode such a big wall, you need a lot of sediments and large amount of time will also be taken. In that case, the possible catchment area where the water or the sediments got accumulated or got from is up to this part, and all these things pointed towards this point of the crater, and they breached it. But to breach it, the important factor is we need weak zones. But when impact happens, there will be large amount of fractures induced either radially or concentric. The one of the radial fractures might have gone will act as a weak zones, and these sediments will try to hamper them more. In that way, this crater wall has been breached, and the sediments which comes from this huge part of the bigger crater Digana has entered and deposited these fan deposits. But still, there are other fan deposits which are seen in this part of the crater. They didn't have any breach, and even there are plenty of fan deposits or associated channels present on the bigger crater. That means the huge amount of activity has occurred within this crater, the post formation. the the breached one, the crater wall is roughly 800 meters in high, and the thickness is roughly few kilometers. That means a huge amount of sediments has to be there. When we looked in detail about the stratigraphy, which lies adjacent to this rim breach area, what we observed is we observed layers, the layered sediments. This gives an evidence that there are deposits happening from the crater wall, and they are pointed towards this part from diverse, different channels. And this is the point where it got breached. And once this had breached, the fan started forming. However, here again, the issue on Mars is like there are not plenty of mm, chrisms available or the mineralogical data due to the high dust cover. The dust cover has completely mantled this part of the things. What we can only observe is the primary minerals, and there is no evidence for, though there is evidence for geomorphologically, there are large number of evidence for fluvial activity. There is not that much convincing evidence for the hydrated minerals. What happened on Diana is, the story goes like this. The Noachian dome is roughly 1.2 kilometers in height, and they are older than 4 billion years. This Digana impacted this volcanic dome and excavated nearly 2 kilometers of material. That means it has pierced into this volcano and exposed the underlying material. The further impact further deepened this impact and really exposed the interior of Mars. We got a sample from around roughly 2.2 kilometers, which hosts the primary minerals like olivine and HCP. And this gives the question like, what is the source for the water and the fan deposits being this high? And what we anticipated is like, we have seen few evidence for ridges. These ridges are moraine ridges which origin due to the glacial activity. That means even after all these processes, this place, due to the elevated from the surrounding regions, they are receiving the ice related snow deposits. So earlier, due to his elevated surface, there may be plenty of snow deposited over there. When this impact happened, Digana impact happened, again, there is a very high possibilities that snow can precipitate over there. When this another impact, Digana E impacted, the heat from this impact is sufficient enough, and the hot ejecta, when emplaced over the snow deposits, is sufficient enough to melt it and create the required sediment. Mangold has already given an evidence like how this impact ejecta and the hot ejecta can able to produce meltwater. So that means in this scenario, the snow which was deposited within these mountains was utilized by this impact, and that provided the sufficient sediments to form the fan deposited within the crater. And if you look at this crater, is fully filled with the sediments, and they are uh, rich in fluvial activity. Do such things have a terrestrial analog? Yeah, I have given examples for the snow and precipitations, whether on Earth. This is an Tambora volcano located on Indonesia. Again, this is located on the equatorial region, so we can say there is may not be possibilities for snow deposit at this latitude. However, within this crater, due to the precipitations, the fan deposits will form, and due to seasons and the temporal changes, the deposits form fans, and even they form lakes within this volcano. This is an volcano caldera, top of the volcano and the caldera, and this is the lake formed within a couple of years. And the source for this is precipitation. So precipitation can form such kinds of fans and possible lakes within the volcano caldera. The same scenarios happened on Digana, but there, instead of caldera, the impacts has made the depressions and formed the fan deposits. So if it is precipitation, why not the snow deposits? In near North Canada, there is an headbed volcano, which is chains of volcano. Among them, one is filled with, most of the year it is filled with the snow deposits. However, during summer, there is a melt of such snow due to the solar insolation, whereas in the case of Mars, it is the impact related heat, and that melt has derived deltaic fan deposits, there may be a water within that caldera, and the deposits can come and form the deltaic deposits. So this scenario is also possible. In such case, what we have observed is like this place is the lowest spot within the crater, and the fans has accumulated and they are pointed towards this. Here, possibly once that may be a small lake kind of thing. However, in this case of Digana, the possible source is the snow which got accumulated and formed the things. Whereas in the case of Earth, both the precipitation and snow deposit can form the fans within the lake. However, the latitudinal dependence plays a major role. The comparative examples for the Digana is the current Zero crater where the March 2020 Perseverance rover is there. However, there's some similarity between this Digana and Zero is both of them are rim-breached crater where this part is of the Zero crater has been rim-breached and it formed a delta deposits where there was a huge amount of water once was there. But in case of here, there are not that much water deposited over this part. That's why it formed in fan deposit. However, and the lowermost part or the lowermost topographic part, there may be a possible paleolake once was there in the Digana. This shows that there are many craters on Mars which is having rim breach. For to breach them, we need a huge amount of water. The same scenario holds for good for the Zero crater also, because for the same amount of rim breach, you need lots of water, and the quantity and time required to form this is relatively large. Moving on to the final source, the groundwater, and the examples for the groundwater is obtained from the Tarsus region. Being a high volcanic province, whether the channels which we see on the Tarsus regions is whether fluvial or volcanic is the first question rises. However, there are evidences which reported like by Mognismark and all that there are few locations where there are channels, fluvial related channels present on Mars. This is one location where an impact has been formed near the Zovistolis Mons, and this is the impact, and this is the graben which associated or located near to it, and there are some channels associated with this grabens. This is somewhat similar to the Mangala Valley's channels, where their Mangala Valley's the fluvial origin channels originated from the graben wall. But this one is entirely on the volcanic surface of the Tarsus region. To demarcate whether it is a fluvial or volcanic origin, the best evidence to look for is like the Midchannel islands, which forms in between the rivers. In terrestrial case, in terms of rivers, in between the rivers, there are many isolated islands which are filled with vegetation. They form by the depositional process of the river. And once the water level is relatively lower than the deposited sand, they will try to bifurcate and flow around it. That's how they will form the mid-channel islands. A similar kind of channels was present, island was present on the location where in the Jovistolis region. And apart from that, there are few craters which got eroded by the flow activity. These erosions didn't host any post lava deposits. If there are the lava deposits flowing over this channel, then we will see some kind of deposited over here. But we didn't observe any such kind of things. That means the material which has flown over this channels could be of fluvial in origin. However, there are complexities in this place because the one which you are saying, this platy ridges kind of thing, they are the lava. These lavas are the post flows which occurred after this channel form. That means this region is highly active in terms of fluvial and volcanic, most dominant by volcanic thing. And there are many braided channels. These braided channels forms in the terrestrial and rivers when they are the topographic slope is low and when they are branching around them. Multiple branching channels are seen with eroded materials. And in overall, if you look at over this graben and the three major channels, this is how the topography looks like. The mid-channel highland is at least 200 meters elevated, and if at all the material which is coming from this southeast to northwest, we will see lots of if it a lava has flown, it might have tried to fill these gaps before overtoppling. Whereas if it is water, There is no need to fill it. It will fill and overflow, and the once it sublimes or evaporates over time, the evidence will be gone. So we will still preserve these depressions. And in all the places, the mid-channel islands and the topographic which are tending towards downwards didn't host any such lava deposits. However, at the termini of the channels, there are few lava deposits, but they are from the other parts of the region which was entering into the channel, which is not occurring from this part. They are entering into the channels. That means this region is undergoing a complex surface activity over time. If you look at in detail, this is the graben and how the water has been released from possibly through this graben, and they reached towards the lower end part. And this water release was so diverse, it formed multiple channels within there. Wilson had has given an example for the Mangala Valley formation, where the graben from the graben, the outflow channels has been formed. Whereas there are post evidence over there also where the lava came out and resurfaced some part of this. The same scenario is happening over this part. The earlier terrain has been made by the lava deposits, whereas uh, the recent one is also resurfaced by lava, but the fluvial activity was sandwiched in between these two activities. This is the place where this lava was coming outside the channel, and in some parts it is entering into the channel where the topography allows them. The crater, which was very closely associated with this channel, has been hugely modified. The floor has been depressed, and the floor is not consist of numerous hummocky knobs, and they are tilted towards the center of the crater. That means this crater and that uh, channel has an association. This is what happened in here. This is the impact, and this is the ejecta which has been spread from this impact. Whereas this part, there is not that much continuous ejecta; they are discontinuous. So this gives a clue that the fluvial activity was post this impact scenario. That means that this crater is around 3.1 billion years old, and the the water which flown over this channel is much younger, like around 3 point or younger than 3.1 or very close to 3.1 kind of thing. That means in the recent Amazonian or in the early Amazonian, there was a sporadic fluvial activity on Mars. But how the water came there? That's the question. There are Bamberg et al. And Sato et al. Has given some evidence like if there are some float collapse, that may indicates that something has been drained within this crater. When you see when it was see these knobs which are oriented towards the crater center, the collapse happened in a similar way. That means this is the earlier crater floor. Later it got collapsed. That means something has been removed in the nearby locality. That is the channel. The channel was being drained, and that caused this collapse. Now the question comes is like how the water percolated into the surface and how it came out. How it came out, it's probably due to this impact and this post impact thing. But how did the water was earlier present in the subsurface? The the Cassidy et al. Has given evidence or a hypothesis for the late Noachian icy highlands on Mars. That means during the Noachian period, the most part of the Mars are covered by ice deposits, and the crater is located somewhere here, and the spot is much known for the lava activity. There is a possibility once this lava and ice got interacted, and those interactions will generate lot amount of meltwater, and they may percolate into the surface. This is the recharge mechanism which possibly anticipated over this part. That means it has not only happened in this part. There are huge evidence, a huge amount of water might be percolated into this Tarsus region due to this lava flow in the younger lava flow. However, the thickness of the lava flow and how deep they are percolated remains a question. The location which has shown in the last few slides is one ample evidence where the water which went into the subsurface came out as a catastrophic event during the post-impact thing, and that has formed this large amount of channels. But again, in the early Amazonian, the conditions are not favoring for the superficial water. The possible explanation is like during the catastrophic release, the top surface forms a thin to several thick ice layers which act as an insulating layer. Below that, the water can flow and form and carve the surface and make the traces left over there. In this way here, the lava, which uh, post-dated the deposits has been played a major role in recharging the groundwater, and once or a while that came out at few locations on the Tharsis. What about elsewhere on Mars? Do they have similar scenarios? Yeah, we are working on few places like the craters where there was a channel associated and they have a small deposits within that. And there are another rim breach kind of things where for such rim breaches and to form large number of channels carving the surface and forming the deposits, you need a good amount of water. Until otherwise you don't carve the surface, the wall, the deposits cannot happen. In that way, this is these are the places to be need to be explored, like how they form and how the source for the waters are varying. And in summary, um, the craters, if you look at the most of the landing sites on Mars, where the rovers are going, they like Guso, the Gale, the Zero, and the Endeavour, they all have an association with a channel and they have deposits within that. The very good examples are for the Zazero and the Guser. So there are recent studies on Zero by Mangold and Salsi there, where they have quantified what is the amount of water that required to fill the Zero and to outflow, and how much deposits and how much time it will take. These kinds of craters where they are interacted with the fluvial channels or the potential targets to look for the future missions, and that will give more clues about the astrobial things and the past history of Mars, and even the how the climatic conditions varied. In the case of Dihana, it varied from it exposed a volcanic and it formed a fluvial and later glacial. That means the major diverse geological activities are present in one location itself. That gives to give study how the stratigraphy of climatic conditions varied on Mars. So I end here and open to questions.
All right. Thanks so much, Vijay. You
Yeah.
now open to questions. There are two questions already posted in Q&A.
Okay.
Can you see the
Okay.
Q&A?
Yeah. Yeah. There is a meteorite impact crater known as Lonar Lake in India. Could it be used as analogs to study? Yeah, exactly. There is already few studies on the Lonar Lake because it's typically host a delta deposit. However, the only thing on the case of Lonar is it's a 1.8 kilometer crater, but the craters which there on the Mars with sediment deposits are huge, few tens of kilometers. The zero is more than 40, 50 kilometers, and many craters are in tens of kilometers. That means they have seen diverse activity. If you want, I can share the papers which have already started linking between the Lonar Lake and the Martian craters. The next one, the beginning of the lecture, uh, we saw evidence of channels evolution on Mars. What is the cause of this evolution? Okay. The there are many reasons for avulsions. In the work which I have shown, it is formed in a place between the peak and the wall, that is the floor. However, any small topographical variation which occurring on the surface will make the river to take to divert its path. The possible explanation what we have given on that location is there was some topographical variations which made the channel or to change its path and form the um, deposits.
Maybe
Yeah.
I could ask a question.
Yeah.
Thank you for this extraordinarily fascinating account of the detective work that has gone on about the fluvial status on Mars. Um, I wonder how much of the interpretation is influenced by our experience on terrestrial um, aspects, such as dense atmosphere, winds, ocean, etc. Maybe you could comment on that. But more specifically, you refer to some catastrophic events that made massive percolation
Yeah.
possible of the water that was created by interaction with lava.
Yeah.
What kind of massive or catastrophic events are you talking about?
Okay. uh, to answer the first question, like how to compare with the dense atmosphere of Earth and the past one, the fluvial activity which mostly happened on Mars are in older. They are 3.7 years billion years older, and mostly happened in the Noachian, where the atmosphere is as equivalent to that of what we have the current Earth atmosphere. But the one which the catastrophic which I have shown, or the channel which is on the screen, they are in the early Amazonian. That means only at few places sporadically there was a water outburst on Mars. To outcome such things in the air, when the pressure and the temperature is very low, you need a catastrophic event that may lead to form the fluvial water related thing. Otherwise the sublimation is going to happen. To answer the second part, like how the lava and interacted with ice and made the catastrophic thing, this theory, I have shown only one part of the things. If you look at the screen, where the black square is located, that is the place where this channel has formed, and this entire place has been mantled by ice, or ice deposits has happened in the Noachian epoch. If you convert that in terms of volume, the amount of ice is going to be very huge. And even when the ice is so huge, even if it is lava which was emplacing over the ice, some will percolate and some will sublime or evaporate at that time. The percolation is going to be a large, and that was stored in the surface and below the surface as permafrost or cryosphere. The event to discharge the water is the major thing. Why we saw the channel, the fluvial channel here only because there was a nearby impact. That impact might have released the shock, and if there is any perched aquifer, or it can able to melt, or it can defrost the ice, and that may be released due to these fractures. And when these fractures are already the weak zone, so water will take the weak zones, and when they come out, the atmosphere is not favoring for the liquid condition, it will immediately sublime and form ice sheets. There are a couple of works which have already explained how these ice sheets may be few tens of meters thickness, and that is sufficient enough to act as insulating. When that forms, the water can flow below the surface.
Okay, thank you. Yeah.
So there is one half question by Bala. So I'm answering the other one. Liu, how to distinguish delta from alluvial? Yeah, for delta we need a standing water body. The deposits which are coming from the rivers or channels, when they deposited within a lake where there was water, usually we'll call them as delta. Whereas for alluvial deposits, we no need of any standing water body. Just river comes and deposits the sediments at any flat surface or near flat surface.
Okay, I'll Bala, go ahead, ask your question.
Thank you. Vijayan,
Yeah,
my question is that this Digana and Digana A crater,
yeah,
they appear to be good places to search for life because we have the what volcanic heat.
yeah,
So
exactly.
can you please comment on this? Why not land on Digana?
Yeah. I, as you said, I have already shown an example. It is as similar to Zazero, but only it didn't form a delta deposits. Irrespective of that, it has a fluvial, volcanic, and all sort of glacial activity happen. That means this area has witnessed all sorts of geological process on Mars, and it also forms a very habitable condition, probably when these deposits are mantling the surface. That can be a potential target sites to be explored in future. Even we wrote in the paper like that only. This could be one potential site to be explored in future.
Yeah,
Okay,
India's
thank you.
next Mars mission.
Yeah.
Oh yes, why not?
Yeah, there's a question in the chat box. Can you see it?
Yeah. Just. Oh, yeah. Yeah, this might be a stupid question, but how can one tell the difference between a lava flow feature? Okay, so it's not a stupid question. First of all, it is the first and foremost question asked when we say if a channel on Mars, whether it is a fluvial or volcanic. Here itself, in the screen itself, the black arrows indicates the lava surface. That means it has a platy ridges over the surface. Whereas if you see within this crater, there are no such ridges over there. That means these kind of mid-channel islands and the branching things, only fluid related activity will form. The lava will try to fill, it will try to first, because it is so cohesive, it will try to fill the empty spaces. But whereas the water will drain out, it will not stay long. If at all lava activity happened over here or in any place, we can see by using the morphology and by the mineral, we can easily discriminate out here. Here there are no evidence for spectral signature where we can discriminate whether any fluid evidence was present over there. And the other thing to look over is like when discriminating the lava and the fluvial thing, the fluvial morphologies will be quite different from the lava thing. Suppose the question is posted in this way, like what about the turbulent lava which happens on Hawaiian highlands? They may flow similar to water. In that case also some small islands may form, but still in those islands the lava will be deposited in traces and they can be looked back from the images. But such things are, if it is not there, we can able to say them they are fluvial. With a coat, that is not that much dust covered. If it's a huge dust cover, then we have to look for multiple evidences.
Yeah, so Vijay, is this all based on MRO data?
Yeah, this is from MRO CTX data.
CDX, okay.
Yeah.
All right, if there are no more questions, then let us thank the speaker. Thanks so much, Vijay. It was
Yeah.
a fascinating talk.
Yeah, thank you.
Yeah,
Thank
look
you.
forward to reading your papers.
Yeah.
All right, thank you.
Thank you.
See you all next week. Bye-bye.
Yeah. Bye-bye.
Dimitra, will you hang on a little bit? We can talk a bit here.
Sure.
Come
Can
back.
you have the link with you, right? This is
Uh,
broadcasted. So
yeah, maybe I'll close this and then come back again.
yeah. Let's do
Yeah.
that.
Okay. All right.
Okay.
Bye.